Hello, my name is Gregory Waxman. I'm going to talk about a work named PatchCraft Video Denoising by Deep Modeling and Patch Matching. It is joint work with Professors Michael Elad and Peyman Milan-Far. In this work, we are going to reconstruct clean video sequences from noisy observations. The video denoising problem isn't new. Many algorithms, both classical and deep learning based, were proposed for handling this task. Yet, our algorithm manages to show considerable improvement in denoising performance comparing to the state-of-the-art algorithms. Our general motivation is to employ same similarity property. Since most patches have similar twins in different locations of the same image or video, our core idea is to gather similar patches to blocks and process them jointly. However, the things are not that simple, since breaking an image into patches leads to a local global gap and isn't suitable with convolutional architectures. Our solution, PatchCraft augmentation, employs the self-similarity property, avoiding the problems mentioned above. Before feeding corrupted video to the denoising network, we augment each processed frame with PatchCraft frames. These are built as follows. For each patch of size P, we find n nearest neighbors in a pre-specified spatio-temporal window. Then we construct P groups of n PatchCraft frames by stitching non-overlapping patches together. Look at the example in the slide. This is the processed frame. This is the first nearest neighbor of the left upper patch. This is the first nearest neighbor of the next patch, and so on. Stitching these nearest neighbor patches together, we get the first PatchCraft frame. Using n nearest neighbors for each patch, we get n PatchCraft frames. We repeat this process for patches with any offset from the top left corner. For patches that consist of p pixels, there are p possible offsets. So in total, we construct np PatchCraft frames. I want to emphasize that all these np PatchCraft frames are similar but not identical, because overlapping nearest neighbor patches come from different locations in the video. So all the frames enrich the denoising process. Stitching together patches that come from different locations may cause blood boundary artifacts. An example of such artifacts is shown here. However, the fact that handled video sequence is already noisy leads to reduced artifacts, as you can see here. After building the PatchCraft frames, we stack them as additional activational maps of the original noisy frames and process each noisy frame independently using a neural network. We call this network Spatial CNN. To handle a large number of feature maps, we use separable convolutional layers. Further details regarding the architecture are shown in the paper and poster. Since Spatial CNN doesn't impose an explicit temporal prior on the denoising video sequence, we applied temporal post-filtering using an additional neural network. We call this network Temporal CNN, and its architecture is a three-dimensional extension of DNCNN. The two networks, spatial and temporal, are trained separately. The proposed method, which we call PACNet, PatchCraft Network, can be easily reduced to a single image denoiser with fair performance by omitting the temporal CNN and limiting the nearest neighbor search to a single frame. Now I want to show some results. This slide refers to Gaussian denoising experiments with known sigma. The table reports PKSNAR performance for Davis dataset at 480p resolution. As can be seen, PACNet shows a substantial boost in denoising performance compared with the existing state-of-the-art methods. Here, upper table reports the role of various components of the algorithm. The lower table shows that in experiments with clipped Gaussian noise, PACNet also boosts denoising performance. These figures show visual comparisons of our algorithm with leading alternatives. As can be seen, our method reconstructs video frames more faithfully than the competing algorithms. In summary, exploiting self-similarity in video denoising via neural network is challenging. PACNet is a fully convolutional neural network denoiser for video. It's built of three stages. Find nearest neighbors for each patch and arrange them into PatchCraft frames. Filters the frames spatially while leveraging the neighbors using the PatchCraft frames. Filter the sequence temporally for improving performance and removing flickering. Pros: PACNet achieves state-of-the-art denoising performance. Cons: high computation complexity.